Here's a video about the first part of the Unit 5 solid geometry review for the test. The first question, a prism has a square base with side lengths of 5. The volume of a prism is 50 cubic units. What's the height of the prism? Show or explain the reasoning. So we know that the volume of a prism is going to be the area of the base times the height. And since we have the side lengths, we can find what the area of the base is. So we can find what big B is. And since it's a square, it's going to be 5 times 5, which equals 25 units squared. So that means 50 being the volume is going to equal 25 times whatever the height is. And we can see by dividing by 25 on each side that 2 units is going to be the height. A box company is looking into different possible dimensions for a box that can hold 60 cubic units. Find a set of dimensions for one of the possible box options. Okay, so cubic units, that's a volume. And we can either use the volume equals base times height, but knowing the base is going to be equal to the length times the width, really the volume is going to be length times width times height. And so we need 3 numbers that multiply to 60 for the volume. There's lots of options. You could do 10, 2, and 3. You could do 5, 12, and 1. Really, there's lots of things that you could do. So think of some dimensions for that. Match the two-dimensional figure and the axis of rotation with the solid of rotation that can be formed by rotating the figure using that axis. So if we rotate this triangle around this axis, it's going to create a cone. That's a very bad drawing of it, but this one's going to be a cone, this one will be a cylinder, and this one will be a sphere. It takes 256 square inches of a roll of wrapping paper to completely cover all 6 sides of a small box that is shaped like a rectangular prism with a height of 4 inches. So a couple important things. 256 square inches. Since it says square inches, we can see that that's an area or a surface area. 4 inches, that's our height. The box has been dilated to a larger box that takes 576 square inches of wrapping paper. So this is the dilated area to cover the 6 sides of the box. What is the new height? So first we have to figure out what the scale factor is. And since we're using area, we have to use the k squared equals the dilated area divided by the original area, which that's going to equal 576 divided by 256. That will equal 2.25, sorry. Which that means k squared equals 2.25. Don't forget that that's a square right there, meaning that we have to square root it. So then we get that k is equal to 1.5. That's just scale factor. That just shows you how much the height is going to be dilated. So since height is a length, we have the equation that the new dilated length or height is going to equal the scale factor times the original length or height. So that's 1.5 times 4, which means that the new dilated height equals 6 inches. A circle with an area of 8 pi square centimeters is dilated so that this image has an area of 32 pi square centimeters. What's the scale factor of dilation? So 8 pi is the original and 32 pi is the dilated. So k squared equals 32 pi divided by 8 pi, which means that k is equal to 4. I mean k squared, sorry. And since that's k squared, we want regular k by taking the square root of each side, which was equal to 2. Okay, question number 6. Imagine an upright cone with its base resting on your horizontal desk. So that's kind of like, oopsie. If we have a cone like that, match each plane with the image of the cross section formed by intersecting the plane with the cone. So this one's going to be vertical through the top because it's going to be a triangle. The horizontal one will be the circle because that's going to be the base. And if we cut this at a diagonal, that's going to be the oval. Okay, imagine a right pyramid with its base resting on a horizontal desk. Sketch the cross section formed by intersecting each plane with the pyramid. So I'm going to draw probably the worst pyramid ever. So that's kind of your pyramid. A vertical one passing through the pyramid's apex, that's going to create a triangle. So I'm going to put it right here. It's going to create a triangle. A horizontal one is going to create a square or a rectangle. And a diagonal plane, it's kind of hard to see, but it'll create a trapezoid. Because as it goes diagonal, the space right here is going to be longer than the segment right there. So it's going to be a trapezoid. A right cylinder will create, as we cut it vertically, that is going to create a rectangle. Horizontally, that will be a circle. And diagonally, we'll create an oval. We'll say it like that. Okay, and number 9, a cone has a surface area of 360 pi square inches and a volume of 800 pi cubic inches. The cone is dilated and the surface area of the dilated cone is 2,250 pi square inches. What is the cone's dilated volume? So surface area, volume, those are important. And we have the new surface area. So to find the scale factor, k squared equals new surface area divided by 360 pi. This is equal to 6.25. And since that's squared, we got to square root it all. So that means that k is equal to 2.5. Now, since we want to find the new volume, the equation is the dilated volume equals k cubed times the original volume The original volume is 800 pi. So we will get 12500 pi inches cubed, or that is approximately 39,269.9 inches cubed. Okay, and that's for part 1.